Uh, Hi everyone, this is Miss Linda. Today inshallah we're going to continue with topic 5, electricity and magnetism. We reached question number 3, and this question is related to mechanics, topic 2, and topic 5, electricity and magnetism. Okay, now the question. Let's start the beginning of the question. We have a girl rides a bicycle that is powered by an electric motor. A battery transfers energy to the electric motor. The electromotive force of the battery is 16 volt, and it delivers a charge of 43 kilocoulomb. So we have the electromotive force of the battery, 16 volt. We have the charge Q, 43 kilo 10 to the power 3 coulomb when discharging completely from a full charge. The maximum speed of the girl on the horizontal road is 7 meters per second. So velocity in x direction, 7 meters per second. Okay. 7 meters per second. With energy from the battery alone, the maximum distance that the gear travels under this condition is 20 kilometers. So distance in x direction, I can call it Sx or delta x. For the IB box, most of the IB books, they use the symbol Sx. This equals 20 kilometer, 20 times 10 to the power 3 meter. Show that the time taken to charge is about 3 times 10 to the power 3 second, or 3 kilosecond. So time, just write the formula and substitute. Time will equal distance divided by the velocity in x direction. Distance is 20 times 10 to the power 3 divided by the velocity, or the speed, is 7. And this will be 2,860 seconds. I can round it to 3,000, or 2,900 seconds, and will equal to 3 times 10 to the power 3 second when you write it to scientific notation. B. Deduce that the average power output of the battery is about 240 watt. Now we know the power from the definition. Power, it's energy over time. Energy over time. And energy, we have the conservation of energy. Okay, the girl is moving. So this energy converted to electrical potential energy. So the electrical potential energy will equal Q times the voltage delta V. Q is 43 kilocoulomb, 43 times 10 to the power 3, times the voltage. Voltage of the battery is the electromotive force of the battery, which was 16 volt. And this will equal 6 . Okay. 6.88 times 10 to the power 5 joule. So power will equal this amount of energy, 6 0.88 times 10 to the power 5 divided by the time we've got from the beginning, which was 2,860 or 2,900, and this will give me 240.6, which is around 240 watt if we rounded 240 watt as he wished, between 240 or 241. 241, 240. Okay, so here we use the conservation of energy. Electric potential energy is converted to kinetic energy when the girls start to, or the kinetic energy when she start moving the bicycle, converted to electricity. The girl ride a bicycle that is powered by electric motor. A battery transfer energy to the electric motor. So because of the kinetic energy is converted to electricity. Now, see, we have a friction and air resistance act on a bicycle and the girl when they move. Assume that the energy is transferred from the battery to the electric motor. Deduce the total resistive force that acts on the bicycle and the girl. We can use the other formula for the power, which equals to force times velocity. Power here 240, if you write 240 or 241, because if we lower it up, it's also correct. So we can use the power 241 from part 1 or 240, both is correct, equals force times velocity, velocity 7, divided both sides by 7. So divide both by 7. We will get F equals 241 divided by 7 will be 34 in Newton. Okay. Now the bicycle and the girl have a total mass, the girl and the bicycle, both of them total mass 66 kilogram. The girl rides up a slope, so the direction of motion or acceleration in this direction. The angle is 3 to the horizontal. Calculate the component of the weight for the bicycle and the girl. Now here this is inclined surface. So if we take the inclined surface to be x direction, we'll go to the center here. So this is my x direction. Perpendicular to this inclined surface, it will be y direction. So I have two forces. First force is the weight of the girl and the bicycle, and this force is down. This is Fg. And I have also a force that is opposite to the direction of motion. If the direction of motion in this direction, opposite to the direction of motion always, I will have a friction force. Now here, it doesn't mention friction. He wants me also only to find the component of the weight. Now this weight, I can break it down to x and y component. Okay, so I will have y component. This is Fg in y direction. And I will have x component. This is Fg in x direction. This angle here is the same always as this angle. Always in y direction, it's cosine. So this one, it's Fg cosine the angle. X direction, it it will be sine Fg always for any inclined surface. If you have the angle here and the weight down, this angle is the same as this angle. So always in y direction, it will be sine theta, it will be cosine theta, adjacent always cosine, adjacent Fg cosine. Okay, so this is cosine and this is always sine, always. This is sine and this is cosine if you have inclined surface. So I need the component for that act down the slope. That means I need Fg in x direction, and this will equal Fg sine the angle theta, sine the angle theta. Okay, Fg 66, Fg its mass times free fall acceleration. So free fall acceleration is 10. 66 times 10 will be 660 Newton. So 660 sine 3. And this will equal 34 Newton, between 34 and 35 Newton. Okay, now the battery continues to give an output power of 240 watt. Assume that the resistive force are the same as in part A. So I have the force of resistance in part A was 34. Resistive force means the friction force. The friction force is small f, I'm going to call it small f. Calculate the maximum speed of the bicycle and the girl up the slope. First, I have to find the total forces acting on the girl and the bicycle. The total force I have F, the friction force, beside the force, the component force in x direction. So these two forces together, I have to find the value of these forces. So F total will be the friction force plus Fg sine the angle theta. Friction force is 34 plus Fg sine theta, we just calculated as well, it was 34. So this will give us 668 in Newton. And from the power equation, this time I'm going to use the total force times the velocity. Power is 240. Total force is 68. I don't have the velocity. Divide both sides by 68 by 68, and I will get the velocity will equal 240 divided by 68 equals 3.5 meter per second, 3.5 meter per second. Okay, on other journey up the slope, the girl carries an additional mass. Explain whether carrying this mass will change the maximum distance that the bicycle can travel along the space. The maximum distance will decrease. Why? Because the resistive force will increase, because I add more mass. That means the friction or the resistive force will increase. That means I need more work to more work is required to go up the hill. Okay, now this is for electricity. Now I have the bicycle has a meter that display the current and a terminal potential difference. So here I have the potential difference at 12 volt. Now remember the potential difference was 16. So I have a drop from 16 till 12, 4 volt drop. The electromotive of the cell is 16. Determine the internal resistance of the battery. So if you have a battery, we usually draw the internal resistance next to the battery. Okay, and this is because of the external resistance, I will have a drop in the resistance. This is the original drop in the voltage. The original voltage was 12, and I have a drop of the voltage to 12 volt. Okay, 12 volt. So how can I find R equivalent? Now here is the current that comes out of the battery. If I use Kirchhoff law, total voltage will equal 0. Total voltage will equal 0. So I will have the electromotive force minus I times R minus 12 will equal 0. 16 minus 12 will be 4, will equal I times R. Now the value of I is 6.5. So here 4 will equal 6.5 times R. Divide both sides by 6.5. So divide by 6.5 by 6.5. R will equal 4 divided by 6.5, and this will give us 0.62 ohm. Okay, now the battery is made from an arrangement of 10 identical cells. Calculate the electromotive of one cell. Now these cells, each of them has the same electromotive force, E or epsilon. When you connect batteries in parallel, the voltage will not change. But when you connect them in series, you will increase the voltage. So if you have two cells that is connected in parallel, each one of them, it has electromotive force E. The equivalent electromotive force is still E or epsilon. So here I will have how many? I will have 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. Each one of them has electromotive force E. When they're connected in series, I'm just going to add the total or the equivalent electromotive force or the equivalent voltage, just add them all. So it will be 5 epsilon, 5 epsilon, 5 epsilon or electromotive force will equal 16. So I need the value for the electromotive force for one of them divided by 5, divide both sides by 5. So E will equal 16 divided by 5, and this will give us 3.2 volt. Calculate the internal resistance of one cell. The internal resistance of one cell. Now remember, this is the internal resistance RR. I'm going to draw the same figure without the battery, just with the internal resistance, because I need to find the equivalent resistance. So here I have the configuration is like that, RR, and here same thing, RR, here 5 times 1, 2, 3, 4, and the last one is like that, 5 times. They're connected in parallel, so the equivalent resistance, when they're equal, you take one of them divided by 2. Always when you have resistance that is connected in parallel and all of them are equal, if all of them are equal and you need to find the equivalent resistance, okay, all of them are and I have a 3, so the equivalent resistance will be one of them divided by their numbers, so it will be R divided by 3. So R divided by 2. And here I have the same thing, R divided by 2. R divided by 2. 5 times R divided by 2. 1, 2, 3, 4. 5 times R divided by 2. In the other hand, if you have a resistance that is connected in series and all of them are equivalent, all of them, they have the same value of resistance. So I need to find the equivalent resistance or the total resistance. One of them times their number. So it will be 3. I have 3 here, 3R. One of them times their number. So if one of them is 1 ohm, so it will be 3 ohms, the equivalent resistance. So here, just R over 2 times 5. So R equivalent will be 5 times R over 2. Okay. So 5 times R 5 over 2 times R, it will give me 0.62. All of this will give me 0.62. So 5 over 2, because R equivalent here, we just calculated, it was from this part, it was 0.62. So I need 5 over 2, it's 2.5 R to 2.5 R will be 0.62. Divide both sides by 2.5 and we'll get the internal resistance of one cell will be 0.62 divided by 2.5, and this will be 0.25 ohm. Okay, that's it. We'll continue with the same document next video.